What's up, everyone? So a few years ago I made a Halloween project, a projection mask that let you basically be anything or anyone that you wanted to be. It was a pretty popular project and I've always wanted to make a second version, whatever that means. So it's a few weeks until Halloween right now, and that's going to be my deadline, so let's get to it. Still kind of works. The major problem here is that the projector has to be a certain distance away from the mask to cover the whole thing. As far as I'm aware, there aren't any tiny short throw projectors. Now this is really cool. It's a really tiny laser projector. And what's really interesting is this is always in focus. It's because the laser is bouncing off a tiny MEMS mirror array. So it's just points of light instead of an image being focused through a lens. Unfortunately, this company went out of business because it would have been really promising. But it also has some issues, like when you bump it, it resets. Now, I've tried a number of different ways of using mirrors and lenses and all sorts of things to make a projector work. But now that I think about it, I don't really think that's the way I want to make the second version of this mask. But I do have another idea. I still have one here. Let's see if it works. This is something I built years ago. It's called the Pixel. And it's just a 16 by 16 LED matrix with APA 102 2020 LEDs, which are addressable 2mm by 2mm LEDs. I was thinking, what if I made every panel of the mask its own LED matrix and made them out of circuit boards? I'm pretty sure you can get these LEDs way smaller now too. So my plan now is to use individual addressable LEDs with individual circuit boards as each panel of the mask. So the old mask is a little bit too complicated for that. There's like too many faces and some are too small and it'd be impossible to solder. So what I need to do is find a more simple mask, find or make. I think I know where I can find one, so that I can turn that into circuit boards and then have it made at PCB way and make it that way. I remember I found these really cool papercraft masks by Wintercraft. I wonder if they have anything. This is exactly what I'm looking for, just without the ears. So this is the mask that I purchased from Wintercraft. And I actually reached out to them and asked if I could use it for this project. So you can see it's a bunch of paper templates that you print out, but that's not going to be useful for me. What I need to do is take those paper templates, somehow import them into Fusion 360, and then reassemble it in Fusion 360. The reason I need to do that is because I'm probably going to have to change some dimensions a little bit, and also I have to turn it into a file that I can import into KiCad so that I can put LEDs on it. So what I'm going to do is kind of import them, mess around in Illustrator, make them so that I can import them as a sketch and then kind of extrude them and then go from there trying to put them together. And after piecing them all together, this is what I end up with. This is half of the mask. I had to recreate some of these, change their shape a little bit, because it's really hard to kind of assemble random angles. Like all these angles are just kind of, someone created it without thinking about the angles. So they're all like fractions of angles. So it's really hard to piece it together. When you're doing it with paper, it just naturally happens. But when you're trying to do it in CAD, it's like a nightmare. So what happened was I got it kind of close, and then I would try and do some measurements, see if I could figure out the angle. And if not, then I would just changed the piece slightly so that it fit together. So it's kind of working with planes and what you're given already, and then maybe making a new part to join and connect the dots basically. So these are all individual pieces. But if I take all the surfaces, extrude them, then I can create an actual mask. So this is the test mask that I'm going to 3D print to make sure that it fits my face. It fits. That's the reason why I 3D printed it. I just need to make sure it fit my face. Imagine I made this whole mask and then it didn't fit. Plus it's going to be probably really fragile the way I'm thinking of building it. So now I actually have to take the mask that I made, convert it back into a flat surface. That's going to be the PCB. I think I'm going to make like a panelized PCB where each half of the mask is in its own panel. That way it still fits in my reflow oven and in my pick and place. And then I have to place where the LEDs are going to be. Okay, so let me explain this a little bit. This is the full mask, and this is so I've just mirrored it, but this is, each half is going to be a PCB. KiCad, it's going to be really difficult to put the LEDs in a grid pattern on this. There is a way to do arrays, like component arrays in KiCad, but for this specific way, it's not really going to work because some of them, the grids need to be on a different angle to the way the PCB is. So what I've done in Fusion is I've made a circle, like a component that is pretending to be the LED, but it's a circle of dimensions 1.234 millimeters. And then I've created a grid pattern for each one of these using geometric pattern. And I think this is like an upgrade. You don't get this for free, which is really annoying. But I use it in the trial period. I'll probably never use it again. This is very specific. But what that does is it allows you to put a grid pattern inside each one of these panels that perfectly fits a number of LEDs with whatever spacing you want. So this is how I'm going to position the LEDs in the KiCad program. I'm going to make a script that converts that 1.234 millimeter circle into an LED component, and it's really not that hard to do. So I actually exported a drawing from Fusion 360 as a DXF, so it was the panel for the PCBs and then with all the circles on them. And they were two separate drawings, so the circles was one and then the PCB file, or the outlines, was the other. And KiCad accepts DXF files and you can import them as any line you want. So one could be outlines, the other one could just be like a user drawing that doesn't actually do anything. And then I use my script that I wrote here that will go through, search for all the circles that are sized 1.234, find their center location, and then place the LED component there. Once that's done, you end up with the board and the LEDs. This is a completed board, of course, but it placed a circle at every place where the LEDs are now. And I had to route this, but it was a lot of copy and paste because you can copy and paste all these traces and then place them on each one because they're all the same. And you just do that a lot of times. So now that that is designed, I've sent the files over to PCBWay. That's where I get all my stuff from. Been using them forever. And hopefully they'll be here soon. Cool. 2? There's only 2 broken on this whole panel? How is that possible? Well, one's missing, and this one I can just tell it's not connected to one of the pads. That's it. Out of this whole thing, it worked. That's insane. This one right here. It's not lighting up. I think it's that one. Yes, that one. So we'll hit it with a... Sucks because on these matte black boards, they look so good if you don't have to do any rework, and as soon as you do any rework, they look terrible in that spot because the flux is so hard to clean. But I knew there was going to be at least a couple, and I'm really happy with only there being 2. You can do it. Reflow any second now. There we go. That should be good now. If I didn't fry it. Okay, let's see if that bottom one is working now. Yep, that one's good. Let's check the other one. Okay, connected and... Yes, that's all of them. That is them all. On to the right side. Alright, it's done the second one. Now, this machine is kind of annoying because it is, I mean, it works great for small, simple boards, but, you know, it's got little issues that makes doing a big board really frustrating. But anyways, about halfway through, it started throwing the LEDs. The tape kind of isn't retracting properly, pulling it forward. So it starts to occasionally throw one or put one upside down. Really annoying because you have so many, that means you have to check them and it's not just perfect and it doesn't detect when that happens. It happened on the other one too. So I don't know what's going on, but it's ready to reflow. But before I do, I like to give it a once over, and it's a good thing I did because that one's upside down. I don't touch them. Where else? That might be it. I fixed a bunch already as the machine was running, but there's one upside down right there. I gotta flip over. Just like that. Everything else looks good. Okay, it's kind of funny, I actually don't know the exact number of LEDs. I mean, I could find out easily, but it's like 3,000 or something. And then all the capacitors. I'm about to do something extremely terrifying. Belt grinder meets circuit boards. These little mouse bites on these boards. These are ones I haven't removed, but they also leave a couple little spikes, and the problem is I'm soldering these boards together, so even the little bumps, here's some that have been removed, will be too much. So this all has to be flat, and this is the best way to get a flat surface. And it's not as violent as it sounds and looks. Okay, you see these tabs? The way I'm going to mount them together is by soldering them together like this at whatever angle they need to be. I 3D printed some angle gauges so that I can hold them at the correct angle loosely, and then I'll solder these together, and these are the power and some of them are ground, so that's how they transfer the power across. And for the data, because they didn't line up and it was going to be kind of messy, I just put a solder point on each one, and I'll just run a small wire from here, see it says A to A, and they're all labeled. It's like welding, but with solder. And way more fragile. All right, we got both halves. Check this out. This will be the final connection. Oh yeah. I wonder if it still works. Okay, so I powered it up. It's all connected except for only half the mask has the data wires. Anyways, I powered it up. I kept having to turn the amperage up, and it was kind of weird because I calculated that it should be around 1.5 amps for just the mask being off. But I was like getting up to 3, and then I hooked up to my giant power supply, and all the way up to like 8 amps, and I was being really cautious. But there's definitely a short somewhere, and I was kind of panicking because it could be anywhere. Like I tested all the LEDs, but you know, it's probably one of these solder connections. I've been searching, and I finally just found this one solder joint. Puts out a little bit more heat at 8 amps, and that's definitely it. Let's see here. It's somewhere between these two. Yeah, definitely. Where is that? I gotta set this up on a tripod. So this is a ground, and this plane is a power plane. And when I sanded the edge, it must have got some of the copper from the power plane, and then when I soldered it, it just did this little tiny bridge there. And there might be other ones, but at least I know how to find them. Actually, I just noticed one other thing. So it's probably not all the pads, because on the mouse bites, I remember this one mouse bite was close to the pads, the ground pads. And it's the only one I did that, and I didn't really think it'd be an issue, but the mouse bite has made the copper come slightly further down, whereas you can see along the edge of the board here that it's slightly recessed. So that's why it's now become a bit of copper when I sanded that off. And it shouldn't be an issue anywhere else because these aren't close to any other mouse bites. We'll see. So that should do it. So now it's powered on. All right. We got 5 volts. There's no smoke. 1.8 amps, and they're all off. Crazy. So you can see I've added the wires that connect each panel. It's a bit messy, but I've got some hot glue in there to hold everything down. I've been so focused on the build of the mask and worried that if it's going to work or not, that the controller was basically an afterthought. And since these are just addressable LEDs, there's 1,000 ways to skin this cat. So I threw together these 2 different ways of controlling it with components I had just laying around. This box contains a high current Pololu 5-volt step-down regulator and a board called a Pixel Blaze. These 2 parts here. The Pixel Blaze is a really cool and convenient addressable LED controller. It lets you map and control your addressable LEDs really easily. The mapping part is important because the mask has a really strange arrangement of the LEDs. So what this software allows you to do is assign the LED to the correct XY position on where it should be on the mask. It's really hard to do, but this works pretty well. So for example, on a regular LED matrix, this could be LED 1. This is always LED 1, and this one's always LED 16. But if we imagine the mask is split in the middle here, this could be LED 1, and this could be LED 200 and something, when you would think that on a regular panel it would just go around this way. So that's why the mapping is important. This is because each one of these is its own matrix. So this goes 1, 8, and then 9, whatever, 20, 21, until the panel ends, and then it starts on the next panel where the wire goes. And then this one goes its own panel, and then it goes down here. So it's pretty complicated. So I added this belt hook, this giant 3S battery, And I'm ready for 9 hours of face warming goodness. Does get kind of toasty in here. These are sound reactive. Spectrogram. But the microphone is behind me, so it's not picking me up very well. But it also has an audio port, so you can actually have direct sound without having to read an analog mic. There's one problem with the Pixel Blaze, and that it's not easy to display images and videos on it, which is somewhat of a necessity. That's where the Raspberry Pi comes in. As a test, I connected just a standard logic level so I could control the LEDs with the Raspberry Pi. Actually, this is the one I ripped off the Christmas tree of death. I used Google Sheets to map the locations of the LEDs. This actually took a really long time. If you imagine this whole thing as a grid, this is half the mask. Then this is actually LED 00 in position, but there's no LED there, so you can't call that LED, obviously. So then the first LED right here is actually at 04, or 40, I should say. So then you have to map them in order, but if you want to call LED, whatever this is, T, let's call it T2, then you actually have to call LED 275. So you have to go through them all, you have to send, if you want to send a white value here, then you have to send it through all these and then up to this one. That's why this took me so long to figure out. So now that I've mapped every pixel on the mask, which took forever, of course, this one here, it's actually on the inside of the mask facing your eyes if you want to make your eyes light up. I don't think I mentioned that. Anyways, take all this from your Google Sheet, and there's this website. They actually have this converter that will take the Google Sheet and convert it to a Pixel Blaze map. So I've pasted it into this spot here. I just literally copy and pasted it from the Google Sheet. And now you can see half the mask. That's what it would look like if you were running this rainbow pattern now on half the mask. So basically I'm treating half the mask as just kind of like a flat plane, but trying to skew it in a way that still works, because it's not exactly projection mapping on this, it's just making cool colors. It'd be a whole other ordeal if you were trying to like put a face texture on the whole mask. So you can take this and then you get your output for Pixel Blaze, and it just tells you, and you actually just copy and paste this right into the Pixel Blaze config, and it gives you this shape. But wait, I forgot one thing. I actually have to convert that to recreate it on the mirrored side. So I just made a quick little script to do that in Python again. And then you have the mask in Pixel Blaze. I also created a Python script that correctly maps the pixels of a video file to the mask. It runs at about 8 frames per second, which is good enough. To run the video, you need a PXL file, which is basically just the map. So you can change that file to whatever you want if you have a different map pattern. And then you just need the video file. And when you run it, it displays on the mask. So yeah, that's a little bit more of a breakdown on my LED mask. If you haven't seen the main channel video though, you have to go and check it out. I put a lot more work into the video. It's really fun. I think you'll like it, so don't miss on that. What do you want to see me put on the mask? You should leave a comment below. I played a video of Doom in this video on it, but I really think I should run an actual instance of Doom playing on the mask where you can actually play the game. So I'm going to figure that out, maybe in a future video. Don't forget to join the Discord and like the video, and definitely leave a comment on what you want to see on the mask. Anyways, everyone. Oh, also, I'm streaming on Twitch, so I might do some builds for things on there. Lots of things to do. Everyone, thanks for watching.